Welcome friends. Today we will discuss the chapter number 5 from second section, combustion in SI engine. So various that points that we have to discuss in this chapter according to the syllabus, different contents here. Stages of combustion: ignition lag, flame propagation, factors affecting flame propagation, abnormal combustion, auto ignition, pre-ignition, influence of engine design and operating temperature, variables on knocking, fuel rating, that is octane number and HUCR, requirements of combustion chamber in SI engine and with different types, and lastly I share with you the multiple choice questions. So in examination point of view, various that questions are frequently asked regarding this chapter, that various stages in a SI engine, explain various stages in SI engine, explain P theta diagram in SI engine, which are the different factors which affect the flame speed, what is the knocking, how knocking is occurred in SI engine, what is the auto ignition and pre-ignition, which are the different factors influence on the knocking, what is the fuel rating in SI engine, or try to shorten it on HUCR, or in different types of combustion chamber in SI engine, requirements of combustion chamber, which are the different requirements for SI engine combustion chambers. Likewise, the questions are to be asked. So first we will discuss the first point, that is the combustion. What is meant by combustion? So simply combustion is defined as the rapid combination, chemical combination of hydrogen and carbon, which is the main constituent of fuel, combined with oxygen which is present in the air, thereby liberating the energy in the form of heat. So increase the temperature of exhaust gases. Getting? So this is simply the combustion. So the different conditions are necessary so that the combustion will takes place. Means for the favorable of the combustion. So which are the conditions? The presence of combustible air filled mixture. So whatever the mixture is present in the combustion chamber, it must be combustible. Getting? Second, some means to initiate the mixture. How we are going to initiate this combustible air filled mixture? It is not going to burn automatically. Some initiation must be there to burn the mixture. Means some aids should be there. So for example, spark plug that we are going to use as some means to initiate the mixture. Third one, whatever the spark initiated by the spark plug is going to develop the flame front, and this flame front must be stabilized and propagate in the combustion chamber. So flame propagation means whatever the stabilization and propagation of flame in combustion chamber. So these three conditions are very much necessary for the efficient combustion. Means to take place the combustion, these three stages or conditions are very much important. So as we know that in SI engine, the carburetor supplies the homogeneous air fuel mixture, homogeneous mixture of the petrol and air, and at the end of compression stroke the spark is going to be initiated with the help of spark plug, and thereby it develops the flame front, and this flame front is going to ignite the air fuel mixture, means unburned mixture, and by that way it propagates in the combustion chamber. Getting? So this is simply the combustion. So here you can observe the combustion mixture used for heterogeneous mixture, that is for CI engine, homogeneous mixture is for carburetor engine. Nowadays also the carburetor is replaced by the injection system in case of SI engine. Getting? But here we have to discuss by considering the carburetor engine, by considering the mixture is homogeneous. So here ignition limits, what are the practical limit available or possible for air fuel ratio of the combustible air fuel mixture. So it will lies between 9:1 to the 21:1. 9:1 means the 9 kg of air to the 1 kg of fuel. Getting? So that mixture is rich mixture. 21 as to 1 means 21 kg of air and 1 kg of fuel, means more amount of air, means mixture is a lean mixture. So in between this practical limit, the air fuel ratio is available as a combustible air fuel mixture. Next, we'll discuss the theories of combustion in SI engine. So theories of combustion means how we are going to discuss the process, how the combustion process is carried out in case of SI engine. So generally it is divided in two types, normal combustion and abnormal combustion, means knock free and that is a knocking combustion. So here first we will discuss the normal combustion, how normal combustion is proceed. So figure shows the theoretical P theta diagram, pressure versus crank angle diagram. So it's shown A to B compression process, B to C combustion process, C to D expansion process. In an ideal cycle, it is can be seen from the diagram, the entire pressure rise during the combustion takes place at constant volume, means entire pressure rise will be at TDC only. This combustion is instantaneous, that we are considering that the combustion is instantaneous and the whole pressure rise is at TDC, but in actual it is not possible, it does not happen, in actual it does not happen. So according to the Ricardo's theory of combustion, Sir Ricardo, known as the father of engine research, he imagined the development of flame in two stages inside the combustion chamber. First, the growth and development of the flame propagation, and second, the spread of this flame throughout the combustion chamber. How flame is to be spread in the combustion chamber, means that is the ignition stages, ignition stage, ignition lag stage, and second one, that is a flame propagate, how flame is to be propagated inside the combustion chamber. So according to the Ricardo, there are three stages of combustion in SI engine. So as shown in figure, that is a pressure versus crank angle, that is a actual P theta diagram. In the examination they ask explain the P theta diagram in SI engine or combustion stages in SI engine. Answer is same for both question. Getting? So here the stages are followed in these three categories. It will falls under three categories: ignition lag stage, flame propagation stage, and afterburning stage. Getting? So first stage we will discuss A to B, that is a flame propagation, ignition lag stage. So ignition lag stage means that is a certain time interval between the instant of spark. It is from A to B. This is a ignition lag stage. So there is a certain time interval between instant of spark and instant where there is a noticeable pressure rise on the indicator diagram on this curve. So at point it started, means that is a starting of ignition and starting of combustion. Point A represents the starting of ignition, starting of spark, and point B represents the starting of combustion. Getting? So this is a time, simply it is a time interval, means during which the chemical reaction is going to occur, during which the molecules of fuels are heated up to the self ignition temperature, and that way it ignited and flame is propagated in the combustion chamber. So generally this lag is expressed in terms of crank angle theta. It will be expressed in terms of crank angle theta, and it lies between the 20 degree to 35 degree according to the type of the engine, size of the engine. Also it expressed in the seconds. Getting? So 0.01 second to 0.002 second. That way the ignition lag also express. So again the different parameters will affect this time interval or this angle of crank angle. So first there are different which nature of fuel, which type of fuel is to be used, or air fuel ratio, temperature inside the combustion chamber, pressure inside the combustion chamber, rate of oxidation or burning. Likewise, the different factors are going to affect this process between A to B. So A to B, this is a simply the chemical reaction developing of the flame, means preparation of the flame, during which the flame is going to be prepared. Now at point B, the flame is to be formed, and what is the flame is to be formed? It must be self-sustained. It must be self-sustained and propagate in the combustion chamber. So when flame will be self-sustained, correct? Whatever the flame that will be developed at point B, it must be self-sustained and propagate easily in the combustion chamber. So when it is a self-sustained, so when the rate of heat generated by the burning is greater than heat lost by the flame, means burning heat should be more than the heat lost by flame. Then and then only it possible that the flame is self-sustained. Otherwise, flame will be quench or cool in between the process. Getting it will be quench or diminish if the rate of heat lost by flame is greater after point B. At point B, it is obvious that the rate of heat lost by flame is more. But once it proceed further, what happens? The heat lost by flame should be less and heat generated by the mixture should be more. Getting? So this is a preparatory phase. Preparatory phase is going to be move further, so that it will the flame become the stronger and pressure will be rise. Getting? So at point B, the motoring curve or compression will be deviated. Means curve is to be deviated from the compression. Curve is to be deviated from the compression. Now third stage, that is after burning. Third stage, that is after burning. So combustion will not stop at point C. It will, but it continue after attaining the peak pressure. So at point C, the after burning stage will start. Combustion will not stop at point C, but it will continue after attaining peak pressure, and this combustion is known as after burning. But obvious, the flame velocity is reduces. Flame velocity is reduced in this case, and further pressure is not possible. Though combustion is continue, but further pressurize is not possible in this stage, and piston wheel moves from C to moves into the expansion stroke from C towards the D. Getting? So these are the important stages for the SI engine combustion. Getting? Now we will see the third factors affecting the flame propagation. Which are the different factors is going to affect the flame propagation? So rate of flame propagation affect the combustion process. So before that, what is the flame velocity? So simply the flame velocity is nothing but a velocity of flame front with respect to the unburnt mixture. With respect to the unburnt mixture, that is nothing but a flame velocity, and this flame velocity is very much important for higher combustion efficiency, for better fuel economy, and by that way it will going to provide the efficient combustion in the combustion chamber. So different factors are there. For example, air fuel ratio, compression ratio, load on the engine, turbulence, engine speed, engine size, intake pressure and temperature. So these are the different factors are there which are going to affect the flame propagation or flame speed. So first we will see the air fuel ratio. If air fuel ratio is rich, then flame speed that is higher. If air fuel ratio is rich, flame speed is higher. If the air fuel ratio is lean, then obviously the flame speed is lower, because lean mixture means there is more amount of fuel, and less fuel means the temperature is lower with the lean mixture. Same time, very rich mixture or too rich mixture is not also desirable, because too rich mixture is also results in incomplete combustion, and it may cools or quench the flame between the process. Getting? So slightly rich mixture is desirable. Getting? Slightly rich mixture is desirable for the higher flame speed. Second, compression ratio. So it is obvious that higher the compression ratio, which will result in higher pressure and temperature, and thereby it going to reduces the ignition lag. Getting, thereby it reduces the ignition lag, and thereby it increases the maximum pressure inside the engine cylinder. Same time it increases the mean effective pressure inside the engine cylinder, and thereby it reduces the ignition lag period, and thereby it increases the higher flame speed, means flame propagation speed will be higher with higher compression ratio. Load on the engine. So load on the engine when increases, load increases, flame speed also increases, means at the higher load the flame speed also increases, because the load increases, it increases the cyclic pressure inside the combustion chamber, thereby it reduces the delay period, and thereby it increases the flame velocity. At the lower load the combustion is poor, which will result in higher emissions, and also which will result in a lower flame propagation or lower flame speed. So load on the engine, it is desirable to work the engine, to operate the engine at the higher load. Fourth one is turbulence. So turbulence plays important role in the combustion, getting, to get the better flame. So turbulence is very much important, getting. So the flame speed is directly proportional to the turbulence, getting. Flame speed is directly proportional to the turbulence. So what happens if the turbulence is more, means it is going to going to mix the mixture rapidly, getting, it will going to mix the mixture rapidly. Same time it increases the heat transfer coefficient between the burned mixture and unburned mixture. So mixture is efficient, mixture is effective with the high turbulence. Same time heat transfer rate also more between the burned mixture and unburned mixture, getting. So flame speed directly proportional to the turbulence. So how we will get the better turbulence in the combustion chamber? So by proper geometry, by the proper design of the combustion chamber, we get the better turbulence. By proper geometry of the cylinder head and the piston crown, we get the better turbulence. Next, it is the engine speed. Engine speed is again linearly proportional with the flame velocity. As engine speed increases, flame velocity also increases. Because the engine speed increases, turbulence increases, in turn it increases the flame velocity or flame propagation. Engine size, if the engine size is double, what happens? The time required for the flame propagation will be also double, but in terms of second only. In terms of crank angle, it remains constant irrespective of the engine size, getting. So engine size in terms of second it increases, but in terms of crank angle it remains same. So for ours, in terms of crank angle is very much important. Next, intake temperature and pressure. So initial temperature and pressure, increases, which results in a homogeneous air fuel mixture, and thereby it increases the higher flame speed or higher flame propagation. So these are the important factors are there which will affect the combustion process, which will affect the combustion process along with the flame propagation and flame speed. So thank you. So remaining that content we will see in the next lecture. Thank you.